Okay, let's do 8b. Suppose we pick a variable uniformly at random from the set and set it to false. The remaining variables are I, D, Bernoulli with parameter half. What's the probability that A1 is true provided that C is true? So again, we're trying to find A1 equal to 1 given C equal to 1. Again, we expand it with Bayes' rule. So let's first find the probability that C is equal to 1. This is slightly different from part A because we have one more step before we assign. We pick a variable uniformly at random and set it to false. So let's say we pick one random variable and set it to false. Then what it means is that the clause that the random variable belongs to is already false, right? So now we already know that one clause is false, and now we look at the rest of the n-1 clauses. So the probability that the rest of the n-1 clauses are not all false is just the probability that C is true, right? So C equal to 1 is probability that C is true is equal to 1 minus the probability that all the rest of the n-1 clauses will be false. So 1 minus that is the probability that C will be true. Okay. Now let's break the probability that A1 equal to 1 intersect C equal to 1 into three parts, depending on what D is. Okay, let's define D first. D is the random variable chosen to be set to false. Okay, so let's see if A1 equal to 1 and C equal to 1 and D equal to A1, so meaning that at the beginning we chose A1 to be false, okay, plus the second part, A1 equal to 1 intersect C equal to 1 intersect D equal to B1, so we set B1 to false at the beginning, plus A1 equal to 1 intersect C equal to 1 intersect D is not equal to A1 or B1. Okay, let's first look at this part. Pay attention here. A1 equal to 1, meaning that we set A1 to true. However, D equal to A1, meaning that we pick A1 and set it to false. So these two events are actually disjoint. So their joint distribution, their joint probability is 0. Now look at this part. A1 is set to 1 with probability half, okay? And D is B1 with probability 1 over 2n, because there are two choices of D, and we pick specifically B1, so it's 1 over 2n times. Now we know that A1 is true and B1 is false, so the first clause is false, right? Then we need to look at the rest of the n-1 clauses. The rest of the n-1 clauses couldn't all be false to make C true, so the probability that C will be true is 1 minus 3 over 4 to the power of n-1, just to make sure that all the n-1 clauses are false. Okay, plus the last one. Okay, here A is equal to 1 with probability half, and D is not A1 or B1 with probability 2n minus 2 over 2n. Okay, and times. There are two cases. We'll further break it into two small cases. The first case is B1 is 1, so B1 is true. This happens with probability half. And now we know that B1 is true here, and also A1 is true here. Then C is true with probability 1. This is first case. The second case, that with a half chance, B1 is 0, so it's false. Then the first clause is false, we already know. And now to make C equal to 1, we shall look at the rest of the n-1 clauses. However, among the rest of the n-1 clauses, one variable, D, is already set to false. So it means that another clause is already known to be false. So there are two clauses that we already know are false. So we exclude this two, and then for the rest of n minus 2 clauses, to make C to be true, like they couldn't all be false. So bad probability is 1 minus 3 over 4 to the power of n minus 2. Right? Okay. So now we write this out. 0 plus 1 over 4n times 1 minus 3 over 4 to the power of n minus 1 plus a half times, simplify this thing, n minus 1 over n, okay, times, simplify it, becomes 1 minus a half times 3 over 4 to the power of n minus 2. Okay, now plug these two into the original base rule thing. We have probability of A1 equal to true given C equal to true is equal to, okay, this whole thing is the numerator, and becomes 1 over 4n times 1 minus 3 over 4 to the power of n minus 1 plus 2n minus 1 times 1 minus a half times 3 over 4 to the power of n minus 2. And the denominator is here. So 1 minus 3 over 4 to the power of n minus 1. Okay, so eventually this will give us the first thing, 1 over 4n, and the second thing, n minus 1 to n times 1 minus a half, 3 over 4 to the power of n minus 2 over 1 minus 3 over 4 to the power of n minus 1. Okay, so this is the final result.